Hello, everyone, and welcome to the first of many episodes in an educational series I like to call Prehistoric Animal of the Day, a series of short films where I talk about a selected individual animal or group of animals and discuss some key topics relating to their discovery, their relationship to modern animals, and what they looked like and how they behaved in life. For the first episode in this series, we're talking about one of the oldest predatory animals on the planet, Anomalocaris, the quote-unquote strange shrimp of the Cambrian. Anomalocaris was discovered and named in 1909 by American invertebrate paleontologist Dr. Charles Doolittle Walcott. Invertebrate paleontologist is a fancy term meaning he was a scientist who studied fossils of animals that lack a backbone, like worms, jellyfish, crustaceans, those sorts of creatures. Anyway, Walcott had led an expedition out to the mountains of British Columbia in Canada, which is neither British nor Columbian, by the way, in search of fossils dating back some 530 million years ago, during a time in Earth's history known as the Cambrian period. Now, if you've ever taken a biology or geology class, then you probably know that the Cambrian is famous for its extreme burst of evolutionary diversity, with some of the oldest animals known to develop eyes, limbs, spikes, shells, and exoskeletons lived during this time period, versus the much simpler, squishy, soft-bodied organisms from the previous pre-Cambrian age. It's almost an explosion of evolution, if you so please.
It's the Cambrian explosion.
Walcott and his team uncovered many of these Cambrian creatures out of the rocks of the Burgess Shale, from trilobites to weird, spiky caterpillar-like animals properly named hallucigenia, to the equally strange, five-eyed opabinia. These things looked like something out of a Dr. Seuss fever dream, but the weirdest was yet to be revealed. Amongst these fossil oddities was the remains of a small animal that looked like a cross between an inchworm and a shrimp. Walcott called them Anomalocaris, or strange shrimp. Alongside these strange shrimp were also fossils of small rounded discs, divided into multiple segments, with a hole at the center. Walcott thought these were some form of jellyfish or related cnidarian, but it wasn't until a complete fossil was uncovered that the true uniqueness of this strange shrimp was revealed. A few years afterward, these fossils were uncovered. As it turns out, the strange shrimp and the odd jelly were not two separate animals, but body parts belonging to the same animal. The strange shrimp ended up being appendages at the front of the animal's face. The odd jellyfish turned out to be a circular, jawless mouth. Not only that, but this animal had two compound eyes situated on stalks, as well as a long, segmented body with symmetrical flaps on both sides of each segment, in similar vein to the aforementioned trilobites and opabinia. It was also very big. At a whole meter in length, this animal was and is the biggest animal known from the Burgess Shale. Since Anomalocaris was the first name attributed to the animal, it kept that name, a title rather fitting considering its taxonomic affiliations. Speaking of which, based on anatomical characteristics such as a segmented body and compound eyes made up of tiny crystals called ommatidia, Anomalocaris looks very bug-like, and indeed a curious observer wouldn't be incorrect in making that suggestion. The scientific name for the phylum that includes bugs, insects, arachnids, crustaceans, and all other creepy crawlies is called the arthropods, or jointed limbs. Many of the fossil animals from the Cambrian are arthropods, including our strange friend. However, despite the shrimp terminology in its title, Anomalocaris was not a crustacean, nor was it part of any living arthropod class. Instead, it was a stem arthropod, or proto-arthropod, that belonged to the extinct clade Radiodonta, which means spiral-toothed, in reference to their circular mouths. One of Anomalocaris' closest relatives is the filter-feeding Thomisiacaris from the Cambrian of Greenland, which used its long, feather-like appendages to capture small, drifting plankton, much like whales do today with their baleen. If Anomalocaris was the arthropod equivalent to a killer whale, The Anomalocaris was the arthropod equivalent to a blue whale or humpback. As previously mentioned, Anomalocaris lived 530 million years ago during the Middle Cambrian period. There is no evidence to suggest this species survived into the later parts of the Cambrian or into the later Ordovician period, but its later relatives did. Unfortunately, fossils of radiodonts stopped showing up past Ordovician-aged rocks, and it's likely they died out during a horrific mass extinction that marked the end of that time period. Earth looked very different 500 million years ago. The mountains where the Burgess Shale sits now were once the seafloor of a warm tropical lagoon off the northeastern side of the extinct continent Laurentia. Extreme geological movement in the ancient tectonic plates caused mudslides to occur, burying and, by proxy, fossilizing the small animals living in the surrounding waters below. Hence why the fossils of the Burgess Shale are not only numerous, but beautifully preserved in tantalizing detail. Living alongside Anomalocaris were plenty of other Cambrian oddities, including the aforementioned trilobites, Hallucigenia, Opabinia, the shield-headed Morella, the spiky urchin-like Wiwagia, the reef-building archaeocyathid sponges, the early chordate Picaya, and the cannibalistic penis worm Ottoia. Not joking about that last one, by the way. The true diet of Anomalocaris has been debated for years now. Its calculating eyesight and sharp mouthparts suggest it was a predator to some degree, but what animals it was adapted to hunt for is still a mystery. Originally, it was thought that Anomalocaris was adapted for hunting trilobites, flipping them over and feasting on their soft undersides, as is traditionally portrayed in many a documentary film. However, more recent studies suggest that Anomalocaris was likely more adapted for chasing down and hunting soft-bodied, free-swimming prey. That said, there are multiple bite marks on the fossils of the trilobite Elrathia that have been attributed to Anomalocaris, or perhaps a smaller, related species of radiodont more adapted to hunting trilobites than even Anomalocaris. We just have yet to find such an animal. Being the top predator of its environment, Anomalocaris had little to fear in the way of natural predators, except as youngsters where they were obviously most vulnerable to attack from secondary predators, as well as adult Anomalocaris, as I have no doubt these guys were likely cannibalistic to a certain degree. Otherwise, the biggest threat to an adult Anomalocaris would have been the aforementioned giant earthquake-induced mudslides that would have engulfed and suffocated any animal caught in their wakes. Sudden changes in temperature, especially colder climates, may have also done damage to Anomalocaris populations, considering they evolved to survive in a rather warm, tropical climate. So if you ever decide to clone an Anomalocaris and keep it as a pet in a fish tank, though I'm not sure why you'd ever want to do that, make sure that his tank is properly warm. And that concludes everything I wanted to say about Anomalocaris. I hope you enjoyed watching this video just as much as I enjoyed making it. I have plenty more of these videos planned, so stay tuned for tomorrow when I talk about the weird Triassic pseudo-dinosaur crocodilian Ephigia. Otherwise, be sure to like this video and share it with your friends. If you feel as though there were any important information I missed, or something I said but got wrong, please feel free to correct me in the comments section. I'll also link the sources where I get my info from in the description below, so be sure to give those a look over as they also go deeper into explanation about the topics discussed in this video. I'm Andrew, and I'll see you next time. Goodbye.
A tasty snack indeed.
Cannibalistic penis worm